Today we're starting the trig portion of the course. Let's make sure you have the pre-printed notes that I gave you in class in front of you, and you're also going to need your graphing calculator. So if you don't have those things in front of you, pause the video, get what you need, and come back and we'll begin. Alright, trig deals with right triangles, and to be a right triangle, one angle of the triangle must be a 90-degree angle. The side across from the right angle is called your hypotenuse, and we can abbreviate it this year with HYPT. The two other sides are called your legs. The legs are what form the 90-degree angle. Every triangle is labeled by angles and side. The angles are measured with capital letters. Let's call this one ABC, and always goes in clockwise formation. The sides are labeled with lowercase letters. So across from angle A would be side little a, across from angle B would be side little b, and across from angle C would be side little c. Pythagorean theorem helps you to determine the measurements of the sides. A squared plus b squared equals c squared. Please remember your c value in the Pythagorean theorem is always your hypotenuse. There are measures of sides called Pythagorean triples. These are numbers that always work with the Pythagorean theorem. For example, 3, 4, 5 works because 3 squared plus 4 squared equals 5 squared. So does 5, 12, 13, and 8, 15, 17. Multiples of these numbers also work. Multiples would mean, for example, for 3, 4, 5, I could have 6, 8, 10. I multiplied all of them by 2, and 6 squared plus 8 squared would also give me 10 squared. Trig functions. You have to know the sine, cosine, and tangent ratios by heart, and I think you already memorized these in years prior. Some of you may have memorized it by saying SOHCAHTOA. Some might have done Oscar hit a heap of apples. However you memorize it, it's going to help you to actually know these ratios. But what you also have to know about these ratios is that opposite and adjacent sides are interchangeable depending on from which angle you're looking from. Now when we actually label our sides using sine, cosine, and tangent for opposite and adjacent hypotenuse, we never look from the 90-degree angle. We always go off of one of the other angles. So if we're going off of this angle here, this side here is my opposite, and this side here is my adjacent, which means next to. And of course, across from the 90-degree angle is always your hypotenuse. But look what happens when we go from this angle here. My hypotenuse is not going to change because it is across from the 90-degree angle still. But my opposite and my adjacent sides are going to change. So opposite and adjacent are interchangeable depending on from which angle you're looking from. Alright, they want us to actually write trig functions as fractions using the following information. In triangle ABC, which is a right triangle, the measure of angle C is 90 degrees. A to C is 5, B to C is 12, and A to B is 13, which makes sense because 5 squared plus 12 squared will give me 13 squared. So they want me to write the trig ratios from that triangle as fractions. Alright, let's review sine, cosine, and tangent real quickly. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Alright, I want you to pause the video and complete A through F and then come back and we'll compare your answers to mine. Alright, now that you're finished, let's see how well you did. For letter A, did you get 12 over 5? For sine of A, did you get 12/13? For letter C, or cosine of A, did you get 5/13? Now you switched angles you were looking from, so basically your opposite and adjacent sides also switched. So for letter D, you should have gotten 5 over 12. Sine of B is 5 over 13. And cosine of B is 12 over 13. Alright, hopefully you did very well. If you didn't, you might want to pause the video, recheck your answers, and see where you went wrong. Alright, in triangle WXY is an equilateral triangle with WX 6 and XZ perpendicular to WY. Alright, WX is 6, and if it's equilateral, XY is 6, and so is WY. And if it's perpendicular, that means I have two right angles, and perpendicular means that these two sections would be 3 and 3 to make the 6. Okay? In each case, find the exact value of the measure of the trigonometric ratio, expressing the value in simplest radical form if necessary. I don't have any radicals, so let's see what happens here. Let's see where we're going to end up with a radical, where it's going to come from. All right, they want me to find side WY. WY we labeled as 6. So we have that. WZ is 3. We have that. XZ, we don't have that. But XZ is part of both right triangles. So if we just look at one right triangle and find that side, or we can use Pythagorean theorem. So we'll go a squared plus b squared equals c squared. We'll say 3 squared plus b squared equals 6 squared. 6 has to be the hypotenuse because it's directly across from the 90-degree angle. 9 plus b squared equals 36. B squared equals 27. Square root both sides. B equals 3 radical 3. Oh, there's my simplest radical form. If you don't know where I got 3 radical 3 from, please remember that. 27 is 9 times 3. The square root of 9 is 3, so it's 3 radical 3. All right, so xz is now 3 radical 3. So let's put that in here. Okay. Sine of w, sine is opposite over hypotenuse, which would be 3 radical 3 over 6, which can be reduced to radical 3 over 2. Okay. Cosine of w, which is adjacent over hypotenuse, is 3 over 6, which can be reduced to 1/2. And yes, you have to reduce if you can. And tangent, opposite over adjacent, will be 3 radical 3 over 3, which reduces to just plain old radical 3. Okay, so I guess that's where simplest radical form came to. Let's go. All right, solving right triangles. Given two measures in a right angle, either one side and one angle or two sides, you can find the measures of the remaining sides using trig. To choose the appropriate trig functions, first identify the placement of the sides of the triangle with respect to the particular angle. Recall your trigonometric ratios of sine, cosine, and tangent. Make sure your calculator is in degree mode. That's very important. You're going to right now go to your mode button. Make sure degree is highlighted. If it's not, do that. Hit enter and then clear. Okay. Find to the nearest tenth the length of the side whose measure is represented by x. Remember, we're never allowed to go from the right angle. So we're going to go from this 42-degree angle. According to the 42-degree angle, we have the opposite and we have the hypotenuse sides labeled, or we're looking for one of them. So opposite and hypotenuse is sine, so sine of 42 degrees equals x over 12. All right, we want to solve for x. So the best thing would be to do is multiply both sides by 12. So on the calculator, 12 times the sine of 42 degrees, enter. To the nearest tenth, 8.0 or 8. Perfect. Let's move on. Find to the nearest tenth the length of the side whose measure is represented by x. All right, we're not allowed to go from the 90-degree angle, so we must go from this angle here, which is 63 degrees. So we have opposite and we have adjacent. Opposite and adjacent is tangent. So tangent of 63 degrees equals 10 over x. All right, so let's multiply both sides here by x. And we're going to get x times tangent of 63 degrees. I know you may be saying, well, that didn't help us because we still don't have x by itself, but we're getting there. Now we're going to divide each side by tangent of 63 degrees. So 10 divided by tangent of 63 degrees. I need it to the nearest tenth. You're correct, 5.1. All right, so we just talked about how to find sides when one angle and one side is given. Now they want us to find an angle to the nearest degrees. All right, well, this is the angle we're looking for is x, so this side is opposite of x, and this side is hypotenuse. So it's the sine of, we don't have an angle measure, so it's x equals 5/7. All right, I can't multiply both sides by 7. That's not going to help me to solve for sine of x. I can't multiply both sides by sine because sine's attached to the x. So does anybody remember how to actually find the degree measure when the sides are given? Hopefully somebody said that we have to actually hit the second button in our calculator. So you're going to go second sine, because we're using the sine ratio. Plug in 5 divided by 7, close the parentheses, hit enter, and that should give you your angle measure. And hopefully to the nearest degree you ended up with 46 degrees. Okay, what do we have to do today? Angle of elevation. Angle of elevation was the observers looking up to an object. So your angle of elevation is down here. So that's your angle of elevation. All right, from a point on the ground 36 feet from the foot of a tree. All right, so here's our tree. Point in the ground 36 feet from the tree. There we go. The angle of elevation to the top of the tree contains 40 degrees. So here's the angle of elevation. It's 40 degrees. They want us to find the height of the tree. Call it x. Well, according to the 40-degree angle, we have opposite and we have adjacent. So that's going to give me tangent. So tangent of 40 degrees equals x over 36. I want to solve for x. So I'm going to multiply both sides by 36. And I need it to the nearest foot. Hopefully you ended up with 30 feet. All right, now that we know angle of elevation, let's go on to angle of depression is when you're looking downward. But this is the funny thing about angle of depression. It's not inside the triangle. It's on the outside of the triangle. But you can't use it to solve anything because you need the angles inside the triangle. So you need to actually find this guy here. Well, if you look very closely, x and y actually form a 90-degree angle. So basically, to get x, we can actually do 90 minus y will always give me the angle of depression. So x is your angle of depression. Okay. From the top of a lighthouse 200 feet, an observer, let me move this up a little bit before we finish here, measures the angle of depression of a boat at sea to be 24 feet. Okay, so here's our lighthouse. Nothing fancy. All right, so 200 feet, so this is 200. Angle of depression to a boat at sea. So if I'm looking down to a boat, here's the sea. Angle of depression's out here is 24 degrees. They want me to find to the nearest foot the distance of the boat from the foot of the lighthouse. Call it x. Well, the only thing is I don't have an angle inside the triangle. I know this is the 90-degree one. Ooh, but that's the depression one. And to get the guy on the inside, they both are together 90 degrees. So I can actually say 90 minus 24 is going to give me 66. So the angle in here is 66 degrees. Okay, according to the 66-degree angle, I have opposite and I have adjacent. So I've got tangent of 66 degrees equals x over 200. I'm going to multiply both sides by 200. and I need it to the nearest foot, and I'm going to end up with 449 feet. Perfect. Nice job. Okay, so we're done with basic trig today, and again, if anything wasn't clear, I strongly suggest that you replay the video and go over your notes carefully before you come to class tomorrow. See you then.